So today I want to focus on inserting, reading, saving. I think I'm gonna probably do the read and save, because that means that every change I do later, like inserting, I can already be testing it with a proper system that actually saves the files, correct? So I think I'm gonna be doing that today. I think that's a good idea. Okay, and for that we need two things. Basically, we need to read the file, and to read the file we need to pass something to the program. Basically, I need to pass like some command line argument to the program, and then we can read the file. Just gonna read everything into memory to a string, and from that point we can start working with the file. The next step is gonna be to parse it, to extract basically the data of the to-dos. And then when we save it back, we need to basically undo the parsing, basically recreating the file and saving it. And the file, I think I have an example, right? Yes. So the file we're going to be working is the typical format for tasks in Markdown, right? So this is not done and this is done. And that's, if you look, the idea is that we have this file here and we can actually render it in this application. There you go. So that's the idea. Okie dokie. So let's start by reading the file. To read the file, we need to read something from the terminal. So I guess the idea will be that we pass. Okay, before that, I need to. I think it's s2do, right? So if I do s2do here, it runs. Okay, I'm saying that because if you do Swift run and you pass, I don't know, like example md here, that messes up the system. Because the way this works is that this argument is treated as an argument to the Swift run itself, not to an argument to the binary that you are running, correct? So to say, no, these arguments are going to the binary that I'm running, you actually need to specify the name of the binary. Okay, which is s2do, and as you can see, this works now. The name of the binary, of course, it comes from your package. So cool. So the idea is that we do this and we read this example file, which of course we are not doing now. Okay, argument parser. There you go. So I already imported at the beginning of this process. I already imported two libraries because I knew I will be using them. One is the Swift argument parser, and the other is Swift parsing, because we're going to be needing both things today. So instead, like, there is one thing I want to do which is a little bit weird. Like, let me show you how you're supposed to use the Swift argument parser, which I've used like a lot of times already because I do a lot of like command line stuff. That's how you're supposed to do it. Okay, so you make a struct, which is, it conforms to a parsable comment, and then you implement a run function, and the key thing here is that you annotate this with main, which tells Swift, look for the main, for the thing that you need to run when the binary executes, here. And then the parsable comment conformance does a lot of runtime magic behind the scenes to actually fill the data from the arguments into the variables that you have here. And then in the run, you have access to that, right? So instead of making a parsable command, I just want to parse, because I'm not like, I don't have fancy commands yet, right? So I just need to take the file from here and that's it, moving on. So the thing I want to do is, instead of doing the parsable command, right, I just want to get help from the library to parse, but nothing fancy. So you could even say that it's not even needed, but maybe, I want to set it up in case that later we want to pass more things. So for that, there is like a little bit of functionality that it's kind of like hidden, which you can make an struct, let's call it arguments, and instead of conforming to the parsable command, like we are doing here, we can conform instead to, I think it was called parsable, I think it's this one, parsable arguments, right? And this basically gives you the benefit of parsing the arguments, and I need an argument which I guess I'm gonna call just file, and it's a string and it's a mandatory string, right? So for example, that's the first thing I'm already using the library for. right? Sandy says you should try the async branch with a new async run. It's great. It is amazing, right? And I use that pretty much on all the projects that actually need, you know, something like async and all that stuff, right? But for this, I don't need that. And furthermore, I still don't understand why that branch is not merged. Why every time we need to like or use a branch, or actually I usually just have like a file that I hack and I overwrite it like locally. But it's very annoying. Why is that not merged yet? I don't understand. But yeah, it's very helpful. If anybody wants to actually do async with parsable command, an argument parser, like there is a branch that also merges the two things together. So we have this, and this allows us to use the library to parse basically the arguments without having to do it ourselves. So for that, we can do arguments, and we can use this type, right? And instead of just initializing it, because at that point, then you actually need to provide the data yourself, and you don't want that. Like we can use this parse or exit function, which basically will try to parse things from the arguments, and if something doesn't work, it exits and shows the help, basically, which is also automatically generated from this, right? So now, I don't remember if you can just say leave this empty and it takes it by default. I think it does, right? So if I do this, okay, seems to work, and if I remove the parameter, boom, you see? Try to parse it, it failed the parsing because there is a missing argument for the file. It shows you the usage here. There is no help here because we are not adding any help. Maybe we can add some help here with help. And if I'm not mistaken, you can just say file with markdown task format. Okay, let's compile this. So if we try this now, we see how the message it's part of the help for this. Okay, and you can also trigger this just by saying help. It's the same thing. Okay, but if we just pass the example MD, now we have access to that example MD, basically saying let's have the file path and let's extract the file path from here, and let's print it and exit 1, for example. So just so we see that it's actually working. Exactly. See? And we printed this. Cool. So we have the file. Freeze step done. And again, we could use the proper parsable command, but then I have to move all this code inside, and everything is indented and all that stuff, and I need to start thinking, do I move that into another file? Too much effort, right? So the only thing I want the library for is to actually parse the string, which that's very simple. I could just do what is command line arguments, and I could do 1 because the 0 in theory is the name itself of the binary. So I could just do that, right? But then if it's not there, this is gonna crash. It's not gonna give anything helpful to the user, so I can just use the library and benefit from that, right? So we're using the library for a very specific thing, not for the entire commands functionality. So we have that. Easy. Next thing, so we need to basically, as I said before, we need to parse this. So we need to parse this somehow and basically go for each line, try to find this to know if it's completed or not, and then extract the information from that. So I could try to do that manually, just build like a parser myself, but instead we're going to be using the amazing library from Pointfree, which is called Parsing. Basically the thing you can do is create parsers that are like independent parsers, and then there is a lot of functionality to combine them. We are using the most recent version, which allows us to use result builders, which means we can have parsers that look like the Swift UI DSL. So that's what we're going to be using. So I think I'm going to start saying, okay, I have a to-do line, I guess, and I can make a parser. You can do parse, okay? And here you see it's a block, it's a closure, and in there we are kind of like in a result builder, and here we can start parsing the lines. Okie dokie. So what's the first thing we need to parse? We can parse basically all of this, and to parse all of that, we can just use a string, right? And this is actually gonna start parsing this if it is there. If it's not there, it will fail and report an error. And then we're gonna have something inside, and then we're gonna close and add a space. What do we want inside? We basically want one of two things, right? So we want an empty space or an X. And for that there is another parser builder, which is the one of parser. And here we can say, you know, an empty space or the X. But the situation with these parsers is that since they are like strings, the idea of when you're using a strings, it's kind of like implicitly wrapped into I think it's called a skip parser, right? So you're saying skip this string, and if it finds it, it skips it, otherwise it fails. The problem with doing this for this specific case is the fact that when you are skipping, so basically the parsers do two things. You get an input, which is usually like a, you know, a substring, so you can move the index through the string quickly without having to recreate and reuse memory and all that stuff. Basically, if you use, for example, if you have a string, right, and you want to start trimming things from the start or from the end, every time you do that, you incur a cost of, you know, remapping the memory, reallocating stuff, and copying memory to one other side and all that stuff. Instead, if you use a substring, you can just take from this. This is basically saying, give me a substring from the entire range of the string. You can do that. So at this point, what you have is it's basically like a view. It's called it's the string subsequent, which is a substring. But you can imagine that it's just a view into a part of the string. So you have the original string still there, intact, the entirety of it, but you have like a pointer to a start and an end, right? And you can just move those indexes, and it makes things way, way faster. So the way the parsers work is that when you start parsing, you start eating things from the beginning, right? It's like, okay, if I find this, I just remove it, all right? And the output you get from the parser, it's basically the output from the thing you want to take out, right? The issue is that when you say skip, what you want to take out, if we look at the type, it's what is the output? Yeah, the output is a void. You see that it doesn't return anything, this parser. So this parser is basically like a parser of void. If it succeeds, it returns nothing, basically it returns void. And if it fails, it actually throws an error. But which is perfectly cool for these cases, because for the start and for this bit here, we don't need anything. Like, the only thing we need to check is, it's there, cool. If it's not, it fails. That's it. But for this, we actually want to retain the information and know that we want to do something with it, right? So we could imagine you having to use another parser here. Basically, the idea is that if I have this, I need to map this and basically map the void into like to true. Well, this to false, because we're trying to say that it's not completed. And in this case, we're trying to map it to true, right? So there we have that. Okay. So let's try to exercise this bit of code, right? So let's say that the input is basically the file path. I need to read the file, so I guess I can do here. I can do the file. It's let's try to create a string from the contents of the file, and we can say file path. Okay, and let's just say exit here, and let's print the file. So first, let's see if this works. So I do this, and I should print basically the same thing. Okay, that's correct. So we have the file as a string. What is the next step? The next step is to, as I said before, take a substring out of it. So with this, we treat it as the input to the parser, and now we have a substring to the basically the contents of the file. And once we have that, I want a result, and this result, it's gonna be a try of the to-do line parser, and I tell this parser to parse the input. and I need to basically, it's an input, it's in out, because as I said, every parser modifies the indices of the substring, so you keep eating from the beginning, you know, until you get nothing at the end. So we have this, and if we print the result, okay, the important thing here is I want to check is the type. So the type, it's a bool, you see? So we have all this parser, but the result of this parser is gonna give us a boolean, and that's it. Because this, it's void, and it's ignored. This is also void, and it's ignored. And this one-off, even though we have two parsers, the one-off picks one or the other, the first one that succeeds, basically. So the output of this is one boolean, and this is ignored, and the boolean is kept, so the output of all of this is just a boolean, which is what we see here. So if we print that, this is going to try to parse the first line, and we actually see how it says false, because it parsed all of this, it found the empty space, which it mapped to false, and then it parsed this bit, and we finished, right? Like we didn't tell it to continue or fail if it was not empty or something like that, right? We actually can say here end, I'm pretty sure, if I'm not mistaken, and that should throw an error. Exactly, you see, yeah, it's throwing an error which says it's a fatal error because I'm just throwing it to the top level. But the nice thing is that it throws an error and it's very specific. This is kind of like the new thing they released with this more recent work on the parsing library about reporting errors, and it's super cool because you see exactly the issue. You see, so we set here after this, it's the end of the file, and it's saying expected the end of the input, and there is still all of this, right? So it's super easy to understand where you make the mistakes when parsing. It's such a great addition. Yeah, we need to keep parsing until we reach the end of the line, and for that. I think we need to prefix, I never remember which one is the through up to sequence of elements, no. Through a given sequence, no, I think it's the prefix. Yeah, I think it's this one. If I'm not mistaken, this has a while. Yeah, so it's prefix while. Okay. So prefix while, the character you are checking, it's different than the new line, I guess. I'm not gonna worry about, you know, other kinds of new lines in other operative systems. Let's just keep it simple for now. So I should parse the entire line. And again, to see an error, let me just put end here. So I actually see an error and we can debug it. Yes, see? So it went until the end, and here, when it finds the new line, it's where it stopped. So, because we added this for debugging, it says, yep. Okay. Cool. Another way of debugging, by the way, is here printing the result and also printing the input, because the input is gonna have basically the rest, like what the parsers haven't consumed is gonna be printed. You see? So the new line, so this is a new line that it's part of the file because we haven't consumed it yet, because the prefix stops as soon as it finds this, right? It doesn't consume it. And then we have the next line, which makes sense. And here now we can see how we don't have just a boolean now. So we don't have a boolean from this, which came from this one-off. We also have the content that this prefix, that this parser actually parsed. And you can see how it parsed the first line, like the message from the first task, until it found the new line, and it stopped there, right? So the new line is not part of this. It's still part of the input. Basically, it's part of the rest of the content we haven't consumed yet. So with this, we have one line. I'm not sure if there is a better way of doing this, but it works. So why not? So now the next thing I want to do is to parse multiple lines, right? So we have a to-do line parser, right? And now I want basically a to-dos parser. And for that, since we have one, we can start, composing them together. I could do it in line here, but let's separate it for, easier visibility. And for composing one parser into many parsers, there is the many parser builder. And the only thing you need to do here is just say to-do line, right? So it's gonna keep repeating the same parser until it fails or it reaches the end or whatever. But this parser needs a way to know how to split every iteration, which in our case is very easy because we can just say separator and we can say a new line. So when it finds a new line, that's the end of the parsing, right? So consume it and go to the next one. And I really dislike the trailing closure syntax, multiple trailing closure syntax that they added recently in Swift. And I don't know, I'm still not used to that and I don't think I will ever, but whatever. Okay, so we have a fatal error. Yeah, to-dos parser. Yes, to-dos parser, and I need to use the to-dos parser because I have an array of to-dos down below, so it's complaining. Okay, perfect. So we see how there is nothing here. That's because the rest, like there was nothing in the input. Like we finished completely and there was nothing in the input. Maybe there is a new line though. Let's try to do this. So that's the rest. Just so you can see. So I'm using the print function, which should basically print everything. The separator, it should be a space. So if you see something else that it's not a space, it's because that's part of the content. Exactly. So there is a space, you can see here there is a space, but then there is a new line and a space. So the new line is what it's part of the content. Okay? So for that, to make sure that that's the only thing we expect, we probably, they added, I remember from some of the recent videos from Pointfree, they added this terminator, and I think if I say this, it's basically gonna consume the end of the file. Does that work? Isn't this just because, let's see, isn't this just because I have an end of line here? Yeah, there is an extra line in there, so if I do this and run it again, oops, not this. If I run this again, exactly, see, so now it consumed everything. So yeah, if you add a new line, this terminator is gonna fail because it's gonna find extra things. So what matters is this, basically. What matters is that we have a structured way of reading this basically file, which is unstructured data. So we are converting from a bunch of string data, just a bunch of bytes, into a structured to-do, a structured task that we can actually work. But for now, we still don't have a task. What we have right now, it's just a tuple, an array of tuples, right? So we're still not in a position where we're gonna start working with it. Thankfully, there is an extra parameter on the initializer of the parse where you can give it basically a mapping function that creates the, like, it takes this tuple, which is the result, and you can use it to create an object. In our case, we're gonna create a to-do. I'm gonna say completed, and the task is just $1. So that should compile. Wait, there's one. Because it's a tuple, right? So I need to do this, maybe. Is that the error? I know what's the problem. The problem is that yes, let me show you what's the problem. The problem is that types don't match. Let me see. How can I show you this? I guess I can do a type of this. Let's do this. If I run this, you will see that, yeah, the type of the result is an array of tuples, as I said, but the second argument of the tuple is a substring. It's not a string, which is what it's what this is expecting. So I need to do this, and I can use $1 in theory. So once we have the result, we actually need to create a string out of it. And there you go. You see how now it's not a tuple anymore, it's actually like the to-do, which that's basically the struct, the name of our struct. Cool. And I think that because the argument positions match exactly, I can get rid of this. and use the point notation here to say that you can use this initializer. Can't I? No, because I need to convert it. Yeah, of course. If we had some functional, you know, helpers and stuff like that, we could somehow use that and say that the second argument needs to be converted into a string, you know. Maybe we can convert it to a string here. Let me see. So maybe we can say string init here. And now we can actually go here and say use this notation. What do you think, compiler? Are you happy? Yeah, cool. So I think that's much nicer, because you here see, okay, I'm using this initializer to create to-dos from this parser output, and that's it. And if you go deeper and you need to actually check what are you parsing, then you see that, oh, this is a string and stuff like that. I don't know, I like it. And we still have the same thing. Cool. So to start using this, we can bring, I guess we can bring this up here. Okay. Current time 0, I think we can just say these things, that's fine. This kind of like our data model, and this kind of like UI stuff, so I'm happy moving it here. So the other thing that I want to check is, so the name, yes, so the names are gonna be to do and done, because I'm not supporting multiple lists on the file. The file is just gonna be like a list of tasks and that's it. And it's at the program level when I'm showing it into the UI that I split it. So what I'm gonna do here is basically take the result and filter for the to-dos that are not completed. And I'm gonna do the same here, where I'm gonna filter by the to-dos that are completed. And that's how we have the two lists. So in theory now, if I run this, I should see the ones from the file. Exactly. That is perfect. Cool. So we're now reading the tasks from the file. And we can work with these tasks, mark them as done or not. But of course, nothing has changed, right? If I open the file, it's still the same as before. So we're reading, but not writing, step by step.